Thank you very much. So across Amazon, we have over 1,000 generative AI applications, transforming everything we do from optimizing delivery routes at a very large scale to forecasting inventory. But how do we build agents at this scale? For our teams to be able to ship production-ready generative AI applications, we needed to fundamentally rethink the way we were building agents. So we released Strands Agents. This is an open source SDK for building agents in just a few lines of code. At AWS, open standards runs deep in our DNA. We are members of the Linux Foundation. We also contribute to other projects, such as OpenSearch and Valky. Multiple protocols have emerged in the agentic era, including MCP and A2A. We believe that both protocols have a lot to offer because they offer a standardized way for agents to discover tools and other agents. So this is the reason why AWS has joined the steering committee for MCP and A2A. Also, we believe that by supporting different protocols, we ensure that developers are not just tied to one standard. With Strands, creating an agent is just as simple as installing the package, calling the agent class, and sending it a query. Behind the scene, Strands handles everything for you, from security to the formatting of request and response messages. It's also meant to be provider agnostic, so you can easily switch between providers. We also have the support for MCP and A2A in Strands, which allowed me to very quickly build a demo involving different agents connecting to each other through the A2A protocol, and one agent being connected to tools with the MCP protocol. I'll show you later. So for the MCP integration, it's really easy to expose one of your tools. Just use the MCP tool decorator and expose your tool on an MCP server through the whatever endpoint you're choosing, here 8080. And then give this endpoint to your agent, so your agent is able to discover your tool. For the discussion between agents, I use the A2A protocol. I have 3 different agents, each running on an A2A server on different endpoints. Take those endpoints and give them to a 4th agent, which is called the orchestrator, that has access to all of your agents and is able to decide which one it's going to use. So for my demo, I built a role-playing game. So if you know Dungeons & Dragons, it's pretty much the same mechanics. So you have a user, this is the player, which is interacting with an orchestrator. The orchestrator is connected to different agents, 2 non-playable characters, and 1 game agent that has access to tools. One is a dice rolling function, so it can roll a dice for you, and also a knowledge base that has access to all of the rules of the game. The demo is like this. When you have a player asking a question, the question is sent to the orchestrator, and the orchestrator needs to figure out which agent it needs to call. So here, if you want to roll a die 20, then the agent asks the game agent to roll the die 20 and sends back the result to the gamer. If you ask something else, such as ask the bard to sing a song, then the orchestrator figures that it needs to trigger another agent, that is the bard, to sing the song and send it back to the user. You can also ask any question, such as roll a dexterity check. And the orchestrator needs to figure out, what is the rule for a dexterity check? I need to ask the game agent. And so the game agent looks up at the rules from the knowledge base and says, I need more information about the character to roll this dice. So can you give me those informations? And so the character looks up its character sheets, send back the information to the orchestrator, and then the orchestrator has all of the information it needs to ask the question to the game agent, so the game agent is able to roll a dice and apply the dexterity check. So a lot of things happen in this video. I don't know if, and I'm talking very quickly, but I had to pause sometimes just to show you the mechanics behind this. But what this is showing you is that Strands is just connecting the agents together and the tools together, and it's solely relying on the capabilities of the agents to reason through complex tasks to be able to answer to the question. So what's next? We believe this is just the beginning. We believe that the future of computing will be increasingly agentic, with something probably like this, where you have your phone with your personal assistant, and rather than having an app store, you have an agent store. And all of those agents are experts in something, and they can connect to your personal agent to accomplish tasks for you. So we're going to be here for the next 3 days at Booth D2, so please come and join us, and we'll have a lot of different demos, so we can continue the discussion together. And also, if you want to dive deeper into strands, we have a code sample right here if you want to test it out, also the documentation in the middle, and if you want to go deeper into the details of the agent's architecture and observability, then there's a nice blog article. Thank you very much.